All right, guys, so what we're doing now is I've taken measurements of all of our doors and windows, the ones that we selected, and I've developed this kit in SketchUp, which basically calculates all the cuts we need to make for framing in the doors and windows. So this is really cool because what it allows us to do is it's all automated, and we don't really need to know. Normally what this process involves is you have to add 2 inches to the width of your windows, subtract here, all that kind of stuff. This basically, we have a set of options, and we can change all of this kind of stuff. So let's see, so our first window is actually a double hung casement. So I can select the double hung casement window there, and then with the option dialog, I can set, we've got window height here, and the window height that I've measured is 37.5. And yeah, to answer Jim's question, I've actually measured the sash. The whole thing is designed to take into account the thickness of the jamb and then the space we need to leave around it. So that the height is 37.5, and then the width of the jambs is 44. And then this one, yeah, and I'll apply that. And then also actually what I can do, the mullions are the vertical dividers, and then muntins are the horizontal dividers. So this, on those windows, we've got 0. Those are the ones with the bars that go vertical. And then we've got 4 vertical ones. So let's see what that looks like. See if that sort of approximates the look. Yeah, it looks a little odd, but let's try 3. Yeah, let's go with that. I'm going to move these guys out of the way because we've got several more of these to do. I've got another set of casement windows downstairs. I actually had to replace that one that we chose because the jamb was just not in good enough condition. So I've got another set of casements that are going to go downstairs. And I can enter in, so that one is, let's see, that one is 38 by 28. With a window width of 28. And we can set our sill height there to anything we want. Since that one's downstairs, I think I'm going to set it at about, actually I might leave it at 36. That's a pretty good height. 36 is a good height for a windowsill because you can still put a table under it very easily. So I like doing that if at all possible. Let's see how that looks. Oh, and also we need to change the menu. Yeah, because we've got, in this one case, we've got 0 verticals, and actually we've just got 1, yeah. Yeah, there we go. So that looks like those windows. And I'll just show you, these are also set up so that we can interact with these, so that the windows can actually be opened. And that's kind of handy when we put it into the SketchUp model, because we can actually kind of think about how we want our windows to swing, how that relates to the spaces around it.
Is this like a Windows Doors template that you're using? Or?
Yeah, this is actually a kit that I've made in SketchUp of dynamic components, and it just automates a lot of this work so that we don't have to redo it. And obviously it makes making SketchUp models much easier, so that you can envision this stuff. Yeah. We can go back to the model that we started with and grab one of these scenes. And let me see. And then you can see like how I've framed this. And this was all made faster because I could automate it. If I was hand doing that in SketchUp, it would have taken quite a long time. But because I've done it once and set it up where it's automated, it's much, much faster. Okay, so the next thing is double doors. So I've got a set of double doors here.
The French doors?
The French doors, yeah, exactly. And so those are 65, oh no. The height is 80 inches and the width across is 65. And then there's also another option here that's wall height, and I've got that for an 8-foot or 9-foot. We build everything with 9-foot height just because it gives us a lot more flexibility. But if you want to do a conventional height, you can set that to 8 feet. press apply, and that automatically resizes. So now what we know, what I'm going to do is export these so that we can, we'll have basically like a little drawing of this, and we'll know how long our header needs to be, how many of these pieces of blocking we need to cut, how long that piece needs to be, and all of these intermediate pieces as well. Let's see, we've also got a single casement window. You can see this is, I'll just show you guys, this is a double hung window, or a single hung window rather. And it goes up and down. Should go down, there we go. And then this one is that's a tilt-in. Oh yeah, that's right. So the casement actually has an option for how many. Oh yes, no, that is right. So this one has an option for where we want the hinge located, and as you saw, I've initially got that one set so that it's a bottom hinge, but we can change that and change that to a left hinge or a right hinge. Click on apply, and now it'll hinge open like that. So for this bathroom window, that's what I like to do, is have it hinge to one side. So now I just enter in it's a little bitty window. It's 14 by 30. And the sill height, I will probably push up a little bit, because in a bathroom you usually want it higher. So I might do, let's try 42 inches. That's 3.5 feet. And it's got 0 vertical dividers, and it's got 1 horizontal divider. And I'll click on apply, and there we go. So you can see that actually, because it's such a narrow window, it actually is going to fit between 2 studs, which is pretty cool. This, as you can see, it automatically drops it out when it's below a certain distance apart. Okay. So now the next one is, we've got a tilt-in window. We've got a tilt-in window in the living room, and that one is going to be 34 wide and 28.5 high. This is the one that's got the little squares at the top. I always do the little sketches so that I can remember which window is which. And we were going to do that one a bottom hinge, since it's above where you might have a sofa. And that one has got.
How do you determine if you want it to be hinged in or hinged out? If you want the window to pop in or pop out.
Right. We generally do everything popping in, hinging in, just because we can do a insect screen on the outside then, and you don't have your mechanism. You know, yeah. Okay. You can do the screen on the inside and pop out, but your mechanism then has to go through the insect screen. Yeah. So you do see on a lot of modern windows, they do have that. They're building. Okay. And again, since that's going to go above a sofa, I want that at least 36 inches high. Let's set that, and we'll see how it looks. Okay, it actually still looks low to me. You see what I mean? See how it looks low? So I'm gonna bump that up. I'll try it at 42, and let's see how that looks. Actually, maybe a little bit too high. Yeah, 40 inches. That looks more right to me. Again, this is just an instinct thing. I just think that will look better on the wall if it's a little bit, not quite centered, a little bit higher. Done that one, I've done that one, I've done that one, I've done that and that. I have not done that one. This is the tilt-in window that we're going to do on the second level. And it's going to look kind of like this one. Let me move these over.
So
Mackey, speaking of the move around these sort of framed modules, is that what y'all were talking about in terms of having flexibility once you're
Yes, exactly.
trying to decide if you
And
like where the window is?
exactly. And the other advantage for a setting like this is that we're going to be able to work on these. So we can have like a team of three people working on one, a team of 3 people working on another, and you're not trying to all work on the same wall. In conventional framing, you frame a whole wall down on the floor at once. We can actually, we've got a nice flat concrete floor out there in the warehouse, so we can start framing these inside in there on that nice flat concrete surface, and we should have then a set of modules to then take out. We set them in with the wall, screw all this together, and then all we have to do is tilt the wall up. So it should really speed up our framing process.
So doing this allows us to just to know all the measurements for the entire of all the walls without having to adjust anything. Just like
Exactly, yeah. And now, of course, between these, we'll have, so there will be some extra studs, because obviously there's not going to be, but this is the most complicated part of framing. The running the studs top to bottom, that's really easy. So this,
all the windows are different, right? So
exactly. And all of these, knowing the length of all of these that's the skill or the experience of framing. And so this takes all the guesswork out of that. And even our experienced framers here like this because they're certain, and when they frame it, it's going to work with the window. So let's see, this one is 22 wide. And it's 38 tall. And then, actually, this is actually on the second level, so it's not actually going to be framed like this. So it may not even be relevant that I'm doing it. I'll do it anyways. We'll do ones, and we're going to do the vertical ones. We'll do 3, and hinge location bottom.
And are there any guidelines as to whether window should be hinged on the left or the right inside?
There's not really a guideline per se, but there are things you can think about just where it's going to be opening into. Is it going to block something as it opens? Do you want to be able to kind of look out or lean out of a window from one direction as opposed to another? Those are the main considerations, I think, when you're doing a window. I sometimes also think about which direction do you want the ventilation, because you can crack a window sometimes, and do you want it closer to one side or the other? And of course, the bottom hinge, like this one's the bottom hinge. The bottom hinge is really good for letting air out the top. So it's really good for ventilation, for letting heat out. Okay, so that's pretty much it for our windows. So now what I'm going to do is get rid of these.
what about the half circles?
The half circles we're going to frame a little differently, and I don't have a module set up for that. So that's going to have to be framed, framed out there. And I've already done a mock-up of how I think we're going to do it in SketchUp. But so now what I can do is go to the front view, and I'm going to turn off. It's already in parallel projection, so that's perfect. And what I can do now is I can set up can zoom into each one of these, and I can set this up as a scene. I'm going to set up a scene so that we can see 3 windows at a time. And now what I'm going to do is take the dimension tool in SketchUp, and I'm going to start dimensioning some of these distances. That's a little hard to see on that background, actually. Let me turn that off.
What does dimensioning mean?
You'll see here in a second. Let me edit this.
I guess making it to where you can actually use measurements.
So dimensioning means adding those dimensions, so that what I'm going to do is I'm going to prepare a drawing. Whoops. What I'm going to do is basically prepare a drawing so that we can then take that out on the shop floor and we know what all our dimensions are.
Okay.
So I'm going to dimension that. And that, of course, that dimension is going to be the same all the way across. And you'll notice that it's not quite 9 feet because basically the finish height of the wall is 9 feet. And what we're lacking here is we still have a bottom plate, a sill plate, and then we're going to have a top plate running above it. And so this already takes that into account, so that we end up with a 9-foot finished height. And then I just want to make sure that I get all of the critical dimensions that we're going to need when we get out there.
That's pretty cool.
And you can see as soon as I do this that, 1 foot 7.5, 3 foot 5.5, 2 foot 7.5, these are not exactly round numbers. So it's really handy to have this and not have to be guessing that or using rules of thumb.
Is this a little bit different style headers up top there? Aren't they oftentimes sitting on top?
Yeah, oftentimes you will see them. This is something we've started doing just because a couple of times we've had a situation where we start framing a window, we get all the windows framed in, and then we realize actually this window needs to come up or this window needs to come down. And so by doing the header at the top, it makes the whole process of moving that window significantly easier.
Right.
And
You still have the strength of the header.
you still have the
Just-
strength, yeah, exactly. And
Yeah.
and even just from down the line, if somebody ever wanted to change something, you can turn a window into a door, for instance.
Right.
If you wanted to modify it later.
One less thing to change.
Yeah, absolutely. And if you thought you could even pre-frame, if you thought you might like to add a door or something, you can pre-frame it like that. So really, on all of these, there's going to be 4 critical distances, which is the distance between the bottom piece and the windowsill, or the window framing sill, rather not the actual windowsill, and then the distance between that plate and then that plate. Just hit end on that phone and it won't ring. Oops. Oh yes. And actually, you don't want your dimensions to get crossed, so. Okay. Okay, so now what I'm going to do is I'm going to export this. So I've got an image of it. This is actually, I'm not doing it by walls. It's actually just by the windows. So we're actually going to do these as separate units. So I'll call this modules 1.
You do your window pieces and then build a wall around that.
Mm-hmm.
Do you have a program that shows all that stuff too? The way the walls and...
Goes together?
Yeah.
Yeah, I'm actually going to be adding these into our model later. I just want to do this so that we can get started framing these windows.
So your window, this is based on the 9-foot.
The 9-foot wall,
you're
yes.
doing the measurements, how far down from the ceiling, how far out. Okay.
And so you can see I've only dimensioned that 8 foot 7.5 one time because it's the same all the way across. So now I've got that image. I can go here and we can print this out.
Now, time saving wise, I can see
Yeah.
for people who are continually building houses over and over and over,
Yeah, yeah.
time saving. But for somebody who doesn't have Google SketchUp or doesn't know the program, and then to learn how to use it and then to spend the time, I mean.
Well, this is actually designed. You don't actually really need to know how to use SketchUp. This is very, very simple, and that's basically why. If you were trying to model this in SketchUp, it would be very, very time consuming. But what this allows you to do is, all you need to know how to do is how to select something and then how to modify the options, the component options. Okay. So you really don't need to know all the intricate details of SketchUp. I'm going to send you guys home with a set of this kit so that if you guys want to frame things, you can do this. SketchUp is free, and it's very, very easy to use. It's absolutely the easiest to use 3D modeling program.
Import that into SketchUp.
All you have to do is open the file in SketchUp, and I'll actually put together a little video for you guys explaining how to do that. In fact, why don't we just do it here now? The main tools you need to know in SketchUp are the Move tool, which is M on the keyboard.
Does it run that on a Mac, or does it have to be Windows?
It'll run on both, yeah. The main tool you need to know how to use is Move, and just like in Adobe stuff, if you hit Alt, you see the little plus sign, and that will make a copy. So now whatever you select to move, it will move it as a copy. So that's what I did, you see, to make copies of the windows. And then, like I did earlier, you just select that, go to Component Options, and then you're presented with your options. You just need to input what your window dimensions are, and then you've got it. Those are really, for doing most things that you need to do for this, those are the only tools you really need to use. There's another tool called called Rotate, which is Q on the keyboard, and then you can see that protractor, and you can rotate things however you want to. Not that you'd ever rotate that.
This is like a
that,
little
but-
plugin that you developed for it? Or
Yeah, these are dynamic components, what SketchUp calls dynamic components, and so they're, each one is a,
Oh, sorry, go ahead.
mhm.
On the rotate, if you hold down the shift key, does it like go in 45 or 90 degrees? Does
It will snap, yeah, it will snap it automatically at those dimensions. Okay, so I've got preview now here. I'm going to print this out, and then we'll go out and start framing this. Okay? Does anybody have any questions?
Do you
other
need
than my
Google,
questions?
I mean, do you need Pro to print?
No, no, no. No, you can
really?
print. Yeah, you can
Oh,
print
okay.
from the free version. Any questions? Any other questions?
I missed the beginning of this. So when you did these windows, did you say you just said, I'm going to frame this size of window, and then it gave you the dimensions of where each stud should go and everything?
Yes, exactly. Yeah.
Yeah.
What I measured the sash.
Okay.
So not the jamb, not the box that
Right.
surrounds the window, but the actual sashes. And then this is designed to calculate the space
So
for the
it's
jam
got
and the
the
space
jam
for
in
the
there.
shims. Yeah.
And then you just hit it, and it
Yeah.
popped out
Yeah.
how you should frame it.
Yeah.
And then you just went in afterwards and put the dimensions.
Yeah.
off
That's
to the
right.
side.
What is
Yeah.
the sash exactly?
Yeah, when we go out there, could you like point out the different components of the windows?
Yeah, sure. So basically, like what we were looking at earlier, the piece that moves up and down, say in a conventional window, that's the sash, and the jamb is the box that surrounds the sash.
Okay.
And we typically, so even for a casement window, the piece that actually moves, the piece that's actually hinged, that's the sash, and then the jamb is the thing
Okay.
that holds it.
Sash is actually going around the glass.
Mm-hmm. Yeah,
Yeah.
yeah. And then what actually attaches the window to the framing is the trim. So if you notice the boxes that Carlos built out there, you've got the box that goes, if you're looking straight at it, the window has a box that goes around it, and then he's got almost like ears on the side,
yeah.
wings, yeah. And those wings are actually what will attach the window to these studs, yeah. And that's also why on these, you can see we do on the side, we've got two studs side by side. That's to give us plenty of wood to screw into with the windows.
Okay.
And then the basic principle, this is a system that Darby actually invented. Most people just frame, like I said, the whole wall together. And what we've basically added is just this bottom piece. And as Zach mentioned, we've moved the header up to the top. And that turns this whole window unit into like a portable slab module, yes. And I think it's really good for the reason he already discussed, the fact that you can move it around. It gives you flexibility as you're framing, which is really nice. You don't have to be spot on the first time. You
moving
can,
the header to the
yeah.
top, you mean? That one.
the
Well,
whole
and
unit,
yes,
actually.
basically adding the bottom to it and moving the header to the top turns this into one whole unit. Whereas normally, when in conventional framing, you would just have this bottom piece would just go down and marry up with the sill plate. But then if you wanted to move your whole window, you'd have to reframe it completely, even if you just wanted to move it 3 inches. This gives us that flexibility where we get it in and start framing it, and we think, oh, actually that one needs to be over slightly.
But this
Just
is
unscrew
equally
it
as
and
strong
slide
as
it.
traditional framing?
Yeah, and probably even a little bit stronger, just because we're
You're just
completely
filling in the gaps
encapsulating.
later
Yeah,
between it. And
Yeah,
you're still
exactly.
going on the bottom plate and
Yeah.
everything.
yeah,
And
yeah.
so
Yeah.
And then sort of as modulars there, and they're moving around these being in such small houses
Yeah.
and spaces. you're not necessarily, everything's not going to be necessarily going to be on 16-inch centers.
Yeah, what this module actually does is calculates the even division,
amount.
amounts.
And so what's helpful, I guess, is like people who use standard insulation, which is meant to fit in, but y'all using the icing.
That's true. Yeah,
blows in. You're not having to cut.
Yeah.
You can actually just blow
Yeah,
in
that's
because
true. That's true.
everything's not-
And I suppose I've made this module for that methodology. I could probably make it as well for the 16-inch center methodology. Just depends on what you want. Yeah, and in fact, actually, I think what I'll do here is I will add dimensions for how much space we've got in between. Or I should be doing center lines, actually. Yeah, so that's 15 3/4. So it's close enough that I would actually just say let's go to 16. So yeah, this is for visual representation. This works, but I think in practice we'll probably just do 16 centers. So okay, so we've got that done, printed out. So we can now take that out and start framing. Yeah, and I think Renee's got us some 2x4s. So I think we're all ready to start going. Okay.